As you can see here, it reaches a certain point where the flexibility of the material does not match the bends that we're trying to get out of it. So round 2, we came up with this twisting rig, which again we came up with. We tried to introduce more profiles and give it, I guess, more rigidity in terms of being able to rotate it to very fixed angles. And this was the idea, that we would be able to produce different sorts of twistings off of that simple mechanism, but in the end it was far easier to actually go this route. And what we did was we actually milled all of the profiles along the entire length of the material, and instead of fine-tuning each one to an individual angle, what you see here is we produced all of the profiles, lay the material on top, and then what you see here is the key. And instead of rotating all of them to hit a specific angle, we CNC milled one sectional cut along the profile, and essentially you rotate everything until it hits that jig and all the things lock into place and it's in the shape you need it, and then you lay the piece on. And so what you see here is feedback from our grasshopper model, which was being fine-tuned with the experiments that were going on in Belgium to identify what the maximum amount of twisting we could achieve and the number of amplitudes that we could get out of a single length and a single sheet, because each of them was producing very different material results. And so this grasshopper model was then used to control graphically the different apertures, so we could then begin to define how we saw the elements. And what you see there on the top left is, in blue, the control profile. So that control profile is CNC milled, and all of the rotating jigs are rotated to hit that element. And for the kitchen areas, we also had a series of struggles where in Rhino space, we were always modeling to our exterior surface. And in reality, what we needed to produce was the inner surface. So the inner surface is what they were molding to, and we had very serious material constraints in terms of the maximum radius or minimum radius that the corian strips would actually bend over cleanly. So we went through another rationalization process of rebuilding the model based off of the offset thicknesses of the 13 mil material. What was really interesting is that then what we thought was going to need substructure, none of this actually needed any substructure, and all of the corian ended up being self-supporting because of the changes to the geometry. And so, again, same photo you saw earlier, the thermoforming taken on the site and now hand sanded by a craftsman. This is